On February 28th, the sky performs briefly. 6 planets will share the same twilight horizon, and most people won't even realize it's happening. For less than an hour after sunset, worlds separated by billions of kilometers will appear lined up in a single sweep of the sky. Not in a simulation, not in a telescope image, above you. But here's the part no one tells you. If you step outside just 20 minutes too late, one of them is already gone. This alignment was calculated years in advance using the same gravitational equations that guide spacecraft across the solar system. It's precise, predictable, and incredibly easy to miss. In this video, I'll show you exactly when to look, where to face, and how to avoid the one mistake that could cost you the entire event. This isn't coincidence, it's orbital choreography. Mercury, Venus, Jupiter, Saturn, Uranus, and Neptune all happen to be positioned on the same side of the Sun from Earth's perspective. That shared geometry lifts them above the western horizon shortly after sunset, but only for a narrow window. Planetary motion follows strict gravitational laws. Astronomers can model these positions decades in advance with astonishing accuracy. The same math that predicts eclipses and lands probes on distant worlds predicted this moment. February 28th is when the geometry briefly works in our favor. But here's what makes it intense. Mercury and Saturn sit extremely low in the sky. Mercury especially never climbs high. It hugs the horizon and disappears quickly. The parade begins the moment the sun drops, and starts fading almost immediately after. You're looking at roughly 30 to 45 minutes of optimal visibility. In some locations, even less. Wait for full darkness. Mercury's gone. Look too early. The sky is too bright. There is no replay. That narrow balance is why most people will miss it, not because it isn't real, but because timing matters. Step outside immediately after sunset. Face west, not an hour later. Not when the stars are fully out. Immediately. The planets follow the ecliptic, the same path the sun travels across the sky, forming a gentle diagonal arc rising upward from the horizon. Start with Venus. It will be the brightest object in that region, impossible to ignore. From Venus, it looks slightly upward and to the left. Jupiter will shine steadily, brighter than any surrounding star. Lower in the sky, Saturn will glow softly with a subtle golden tone. And closest to the horizon, faint but present if the air is clear, Mercury. Here's the critical mistake most people make. They wait for perfect darkness. But this is a twilight event. If you wait until the sky looks ideal for stargazing, Mercury will already have slipped below the horizon. And you may not even realize you missed it. Now for the outer giants. Uranus and Neptune are part of this parade too, but they won't jump out at you. You'll need binoculars or a small telescope. Without optical aid, they blend into the background. With it, you extend your vision billions of kilometers farther into space. Location matters more than people think. You need a clear western horizon. Buildings, mountains, or heavy haze can block the lowest planets completely. Even slight elevation, a hill, a rooftop, can dramatically improve your chances. This isn't casual stargazing, it's a timed performance. Miss the cue, and the stage empties. 6 points of light don't sound dramatic until you understand what you're actually seeing. When you look at Venus and Jupiter side by side, you're observing worlds separated by hundreds of millions of kilometers. Add Neptune into that same glance, and you're extending your sight nearly 4.5 billion kilometers from the sun. No human has ever traveled anywhere near that far, and yet, on this evening, they'll appear arranged calmly along one elegant arc, compressed into a single human moment. That contrast is what makes this powerful. The planets are not clustering together in space. They aren't forming a cosmic traffic jam. What you're witnessing is perspective. Earth moving through its orbit at 30 kilometers per second, reaching a position where multiple planetary paths intersect our line of sight at once. This parade exists because we are moving. 4 planet evenings happen occasionally. 5 are rarer. 6, with both naked eye and telescope targets included during twilight, are significantly less common. And here's the deeper layer. This event highlights the reliability of physics. The same gravitational equations predicting this alignment allow space agencies to navigate spacecraft across billions of kilometers with near-perfect precision. The solar system runs on rules, and on February 28th, those rules produce something beautiful. When you step outside, you're not just seeing lights in the sky. You're witnessing celestial mechanics unfolding exactly as predicted. So here's what to remember. February 28th, right after sunset. Face west. Don't wait too long. Give yourself a clear horizon, and if possible, bring binoculars. For less than an hour, nearly half the known planets of our solar system will share one twilight sky. Not in a telescope image, not in a simulation. Above you. Moments like this don't demand equipment or expertise. They only require attention. So here's the real question. When was the last time you witnessed a sky event that truly stopped you in your tracks? Drop your thoughts in the comments. I'm genuinely curious. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching and see you next time